In this video, we're going to explore positive versus negative numbers in a bit more detail. So we already saw a little bit of negative numbers when we had negative exponents, but we didn't really clarify as much as we could have, I suppose. So this is what this video is dedicated for. Imagine you had a number line. So you just listed all the numbers, 0, 1, 2, 3, 4, 5, 6, 7, 8. This goes on forever this way. Now suppose I asked you what 2 plus 3 was. Well, visually on the number line, you would always start at 0, and you would move over by 2 for the 2, and then you're adding 3, so you're moving another 3, 1, 2, 3. And you landed on 5, so 5 would be your answer. So that's all well and fine. What if we did another one here where we had 5 minus 1, let's say. So you would start at 0, and then you would say 5. Let's move over here by 5, and then minus 1. If it's a minus, we have to go backwards by 1. So we're going to move left 1. So we went forward 5, back 1. And we landed on 4. So that's how I know the answer here will be 4. Okay, so this sounds like more work than is necessary. I mean, we've all learned how to add and subtract, but we didn't have to draw out the numbers. Why is this important? Well, I'll show you with positive and negative numbers. Sometimes you can land in the negatives. What if the question was 2 minus 3? Well, okay, we'll start at 0. We go over by 2. And then subtract 3 means move left by 3. 1, 2, 3. And we went past 0. So our number is less than 0. So we actually have to start counting backwards. Minus 1, minus 2, minus 3, minus 4. And this goes on forever this way, just like it goes on forever in the positive direction. So when we move left, we fall into the negatives. So here we landed on negative 1. So the answer would be negative 1. Let's try our example here. So negative 2 minus 4. So this one will be very negative, I suppose. Let's say 0 is here. So if we start going in the positive direction, we'd get 1, 2, 3, 4, and this would keep going. But on the left side, we would get negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, and this keeps going. So negative 2 minus 4, we have to begin at negative 2. Or we start at 0, but we move to negative 2. So we move left by 2. And then we're going to move left by another 4. 1, 2, 3, 4. So notice that they went in the same direction. They were both negative. So it's as though you added the 2 plus the 4, but in the negative direction. So we ended up with negative 6 as our answer. So they worked together in the negative direction. They made negative 6. Is that always the case? Well, let's try with this one. You'll see that they behave a slight bit differently. So let's begin. Start at 0, and we're going to go left by 3 because of -3. Next, there's a plus 4, which means wherever we left off, we need to move to the right 4 times. 1, 2, 3, 4. So we landed on +1. So it seems because we moved more in the right-hand side than we did on the left-hand side, or the negative number here was smaller than the positive side, the positive number. The positive side wins. We traveled more in the positive direction, so our answer was positive. So +1. You could put a +1 as your answer or just 1. Typically people just put the number 1. Okay, so here's one that's a bit different. -2 plus -5. So here's a set of rules for pluses and minuses. If ever you see a plus and a minus, I'm going to say back to back, so one right after the other, then something's going to happen. And actually, I'll do 2 pluses first. If ever you see a plus and another plus, that will make a plus. If you see a plus and a minus, that's going to make a minus. A minus and a plus is going to make a minus. And 2 minuses make a plus. Now, I have to be very careful with how I introduce this to you because I see a lot of people make mistakes with this. This only works when both symbols, I'll call them, the pluses and the minuses, are next to each other. Now, what do I mean by that? Let's take a look here. So we said, for example, a minus and a plus makes a minus. If we look at our previous example, we had a minus and a plus. We had -3 plus 4, but our answer was a +1. So did that not just break the rules? Well, no, it didn't, because we never saw a minus plus. We saw a -3 and then a +4, but we never saw a minus directly next to a plus. If instead I saw something like, let's say, minus +3, maybe there are brackets, maybe there aren't. The brackets don't really change the outcome. That's when the minus and the plus would combine, and then they form a minus. So that's what that means. Please do not get these two things confused. Another time that this would work actually is only when both symbols are next to each other, or you are multiplying or dividing. We'll see that in a little bit with the next few examples. So let's just try this one in the meantime. So -2 plus -5. I see 2 symbols that are next to each other. So this would be -2 minus, because if we go to our rule set, a plus and a minus makes a minus. So that's why I put a minus here. 5. And so what is -2 minus 5? Well, we can take our number line if we're still not sure. So we start at 0, and then we go -2, which is left by 2. And then we go minus 5, which is left by 5. 1, 2, 3, 4, 5. Okay, so we landed on minus 7. So minus 7 is the answer. Another way to look at it is they're both minuses, so they work together. And so 2 plus 5 made the 7. Here we go. Here's one where both are multiplied. So in algebra, sometimes you won't see the X symbol for multiplication. Instead, you'll just see two brackets that are squished together. So another way of looking at or interpreting what this means is minus 3 times minus 4. Now we choose to put brackets just to sort everything out because it's going to get more complicated later. For example, when we see order of operations later, you'll see that you might have something like 3 times 2 plus 5, and then the order will matter. So we'd have to calculate this first and then 3 times whatever the result of that. That's for another video. I'd say for now, let's not worry too much about that. Just remember that brackets that are like this, all that means is that they're multiplied. So what did we say about multiplication in our set of rules? We said that if there is a multiplication of a plus and a plus, it'll make a plus and a minus will make a minus, a multiplication of a minus and a plus will make a minus, and two negatives multiplied together will make a positive. Which example do we have here though? Two negatives. So this is a minus times a minus. So if you recall, a minus and a minus makes a plus. So a minus 3 times minus 4 would make plus something. Well, all we have to do now is figure out what 3 times 4 is, which 3 times 4 is 12. So this would be the final answer. Now you don't have to put the plus, you can just put 12, or you can put plus 12. Oh boy, this one looks a little crazy, but it's nothing we can't figure out because we've done, there's no surprises here. There's a minus and a minus, and they are, I guess in a sense, next to each other. So they're going to make a plus. So this will make a plus 3. I'll keep that in brackets, and I'll just copy the rest. You know, there's no rush. We can take our time. What do we do next? Well, I see here a plus 3 times a minus 4. So remember that a plus times a minus is going to make a minus, and 3 times 4 is 12. So this is minus 12 times the rest, all the rest of the stuff that we haven't figured out yet. Okay, well, there's no symbol here. If there's nothing there, we have to assume that it's a positive or a plus. So this is minus 12 times plus 5, which would make minus 60, times the rest. Okay, what about minus 60 times 0.5? Well, remember that the 0.5 has no symbol in front of it, so we have to assume that it's positive. So that would make a minus times a plus is another minus. 60 times 0.5 is 30, times the rest. We're almost there. Last thing I see here is two minuses that are multiplied together. So two minuses makes a plus. 30 times 0.25 is the same thing as 30 divided by 4. So we're going to get 7.5 as an answer. And that will be our final answer. plus 7.5 or just 7.5. And that's it for positives and negatives. Just remember, when they're multiplied or divided, that's when you use these rules. But if they're added or subtracted, as in the first couple of examples, make sure to use number lines instead. If you use the plus and a plus makes a plus and plus and a minus makes a minus rule, you may get these ones wrong. And I've seen people get these two things confused. So please be careful with these. I'll see you in the next video.